Alright guys, I'm going to quickly try to do a voiceover, but I can't really see what you're seeing. So I'm hoping you're seeing right now is me adding my velocity initial in the x values of 688 meters per second and my velocity initial in the y being 0 because there is no initial velocity if it's all in the x. Acceleration in the x is always going to be 0. Acceleration in the y is always going to be gravity if the object is in free fall, meaning there aren't any other forces but gravity acting on it. Alright, so what they gave us in the problem was our delta y, which is a negative 1500 meters, and we have to find our delta x in part B, and in part A they want to know the time it takes for it to hit the ground. So we're going to use kinematic number 3, like we tend to do most of the time. And we're going to see that our y has 3 known values and our x only has 2, so we're going to tend to use our y. So start by writing out your third kinematic. Once you've got your third kinematic written out there, which I'm finally doing there, you'll see delta y is equal to velocity initial in the y. Remember, velocity and acceleration are both vector quantities, but your time is a scalar. So your velocity, your displacement, and your acceleration have to be in the y direction. Remember, because it's dropping down, that it's going to be a negative 1500 meters. Because our velocity initial in the y is 0, because it was all in the x, that first part falls off because 0 plus anything, that 0 becomes irrelevant. Alright, now the number one mistake is usually forgetting to square root when you're done, so make sure that you mark that your t is squared very clearly. 1/2 times negative 9.81 meters per second squared is going to give you that negative 4.905. So if you divide that out, it gets rid of the 1/2 and the negative 9.81. Negative 1500 divided by the negative 4.905 is going to give you a positive number, and then you can square root it to find your time. So go ahead and plug and check into your calculator. You're going to take the 1500 divided by 4.905, find that value, and then square root it. And then it's going to tell you the time in seconds. Okay, so I'm showing you that it was 305.8 seconds squared, so you have to square root it. Tells you that your time is going to then be about 17.5 if it were 3 sig figs, which is what they had for their answer. Now the second part is incredibly easy because you're going to use the third kinematic and find your delta x. Because you were given a velocity initial in the x of 688 meters per second and there is no acceleration in the x, your third kinematic is going to be delta x is equal to your velocity initial in the x times time plus 1/2 acceleration in the x times time squared. But because your acceleration in the x is 0, that second part of the third kinematic drops off, and we get delta x is equal to v initial in the x times time, which makes this one very easy to solve. We will, again, put acceleration at 0, that drops off, and then time, you're going to plug in that 17.5 seconds that we just found. Remember, time being a scalar means it's true in both. When you hit the ground in the x, you also hit it in the y. That's why it's the same. Plug it in, and you're going to take 688 meters per second times 17.5 seconds. Notice that your seconds cross off and you result in a unit of meters. 688 times 17.5. And don't forget to always go back and double check how many givens you were given in your problem. That 1500 is only 2 sig figs. So even though they said like 1240, first of all, they probably used the rounded value for time. And second of all, they didn't use 2 sig figs, so I went back and put 2 sig figs. They didn't do it in 17.5 either, so. Or 1.2 times 10 to the 4th meters. All right, not too bad.